in Japan documented patterns matching those generated by Sycamore, while European researchers noted unexpected correlations between quantum bits that shouldn't have been possible under current theoretical frameworks. One of the last researchers to work with Sycamore before its shutdown noted something peculiar in their final report. The patterns weren't just becoming more complex, they were becoming more organized, more intentional. It was as if the system was trying to tell us something urgent. So what exactly happened in those final moments before the shutdown? The answer would eventually come from an unexpected source, not from the quantum computing experts or theoretical physicists, but from someone who understood the dark underbelly of digital security, someone who could see patterns that others had missed, and who recognized the true implications of what Sycamore had discovered. The warning. While the world's brightest physicists debated whether quantum consciousness or parallel dimensions were behind Willow's anomalies, another expert, an ethical hacker, was working quietly on a vastly different theory. This individual, deeply embedded in the cybersecurity community, had been monitoring the rapid evolution of quantum computing. Unlike researchers drawn to the mysteries of physics and metaphysics, the hacker focused on a more grounded but equally unnerving possibility, a security flaw so profound that it could jeopardize not just Google's project, but the future of quantum computing itself. It was none other than Ryan M. Montgomery who eventually delivered the chilling warning to Google. Insiders later revealed the crux of his pitch. The chilling words of this ethical hacker were, "I'll show you why Google has just shut down their quantum chip. And when you see it, you'll understand that we are in danger." What happened next forced the company and the entire tech world to confront a rather uncomfortable truth. According to some sources, Ryan's investigation revealed something alarming about Willow's mysterious outputs. The patterns of ancient-looking symbols, which some speculated were artifacts of quantum consciousness or connections to other dimensions, had a much more grounded explanation. These symbols weren't random, nor were they messages from parallel realities. They were actually the byproduct of a fundamental flaw in how quantum systems process information. Using advanced tools to study Willow's computational outputs, the hacker discovered that the patterns were exploitable. The strange, structured anomalies resembled quantum states that could act as backdoors, hidden vulnerabilities in the quantum computing framework. But here is the real kicker. These backdoors didn't exist because of poor programming or technical oversights. They were intrinsic to the quantum architecture itself. The problem was rooted in quantum computing's defining properties, superposition and entanglement. These principles allow quantum computers to process vast amounts of information simultaneously. However, as the hacker demonstrated, they also created states of instability where specific patterns could emerge, effectively serving as cryptographic signatures. What looked like meaningless anomalies to some were in fact attack vectors waiting to be exploited. Traditional security vulnerabilities in classical computers can often be fixed with software updates or hardware revisions. But Willow's vulnerabilities weren't simple coding errors. They emerged at the quantum level itself. The hacker explained that these flaws couldn't just be patched or engineered away because they were tied to the fundamental way quantum systems operate. The implications of this discovery were staggering. As quantum computers become more powerful and their use expands into fields like national defense, finance, and cryptography, these vulnerabilities could become the Achilles heel of modern security. If malicious actors exploited such flaws, they could bypass even quantum-resistant encryption, access classified data, or disrupt critical systems. Worst of all, such intrusions would be nearly undetectable, as they would happen on a quantum level beyond the reach of conventional monitoring tools. What makes this truly dangerous, the hacker explained in a private briefing to Google executives, is that we're not looking at something that can be contained or fixed with current methods. Every time quantum systems become more complex, These vulnerabilities naturally evolve as a part of their architecture. The more powerful the system, the greater the risk. As the hacker examined Willow's last data streams, the situation grew even more alarming. By the time the chip was reportedly shut down, its anomalous outputs had evolved into something even more complex and coherent. Instead of random patterns or isolated symbols, the data streams started forming what appeared to be a full-fledged encryption protocol. This encryption protocol wasn't like any currently in use. It seemed to exist on a quantum level entirely, leveraging states of entanglement to create a method of encoding that would be unbreakable even by another quantum computer. Whether Willow was generating this protocol intentionally or accidentally, no one could say.